hypotenuse.
Yep, hello. This is going to be a video for pulleys for AS Maths, yeah, and how to do them. So, look at this first question. Two particles of a mass 2 kilograms and a mass m are connected by a light, inextensible string that passes over a smooth light pulley, as shown in the diagram below. The particles are released from rest with a string taut. The 2 kilogram particle moves vertically downwards, traveling at 0.8 meters in 2 seconds. Find the acceleration. So for part A for this question, it's basically going to use Suvat equations. Right, so SUVAT, it moves at 0.8 meters, so S is 0.8. It moves in 2 seconds, so we've got 2. And it's given that it's at rest. Here, it's given it's at rest. So we can say our initial velocity is 0, and we want to find acceleration. So you can look at your formula sheet to find which one would be suitable, which equation should be suitable. And you should find out that the best equation for this case would be S is equal to UT plus 1 over 2 AT squared. Because our initial velocity is 0, so that will cancel out. So once we pull in the values, we get 0.8 is equal to a half times A times 2 squared. And solve for A. So we get A is equal to 0.4 meters per second. Squared. Squared. Okay. And now for part B, to find a tension in the string. Now, we got our acceleration, right? And to find a tension in the string, we need to find our initial equation first. So our initial equation of this particle here, I'll choose this particle, would be resultant force is equal to some other two forces. So we're going to think what forces are acting on this particle. So you've got weight acting downwards, right? And then in the wire, we've got tension acting upwards. Tension acting upwards. Right. And now let's go back to the question. Let's go back to the question and see what they say. So they say the particle of 2 kilograms moves vertically downwards. So it's moving it in a downwards direction. So our resultant force, that means our weight must be greater than our tension for it to move downwards, right? If a particle moves downwards, its weight has to be bigger than its tension in order to move downwards. And resultant force is always the sum of these two forces. Right, so we've got weight. However, because tension is in the opposite direction to weight, we have to minus tension because it's not in the same direction. And that gives us our initial equation here. And we can change this equation. If resultant force is equal to F is equal to MA. So we've got MA is equal to mg minus T. Mg is the equation for weight. Now we can plug in our values, 2 kilograms. We've got 2 times the acceleration that we found in the previous question of 0.4. 0.4 is equal to 2 times gravity, 8 minus tension. And resolve this whole equation to get T is equal to, should be around 18.8 if I'm not wrong. Right? Okay, so that's our answer. Newtons. Part C is asking to find the mass. So we look at the equation again. So this particle, we want to find the mass of this particle, right? This particle. That particle since this 2 kilograms going downwards, particle M will going upwards. So see here. Since particle M is going upwards, right, we can use the same equation. F resultant force is equal to, now since it's going upwards, right, that means tension must be greater than the weight. Since it's going upwards, right, because it has to be pulled upwards, which is by the tension. So that means we have tension minus our weight, because weight is in the opposite direction. And the thing to know about pulleys is that tension is constant throughout as long as the string is extendable, yeah. So tension is the same throughout. So we can replace these values with our equation. So resultant force again is equal to F equals to MA. And also the acceleration is the same throughout. So we can still use this acceleration. If we get M times 0.4 is equal to tension minus M times 9.8, which is weight. Since tension is the same throughout, this tension will be equal to our tension over here. So we can plug that in, get 0.4 M is equal to 18.8 minus 9.8 M. Move this over to move the 9.8 to the other side. We get, that would be 10.2 M is equal to 18.8. Put that into your calculator. And we get M is equal to 1.84 kilograms, roughly. You'll get 8.843, but just in 2 decimal places, it makes it easier. That's the answer for that question. For this next question, question 5, it's a bit harder than the previous question. So let's go through it. A light inextensible string has a particle of mass 8 kilograms attached to one end, and a particle of mass 12 kilograms attached to the other end. The string passes over a smooth light pulley. Particles are released from rest. The string taut and vertical on each side of the pulley. The diagram shows the pulley on the particles. So yeah, by forming an equation of motion, for each of the particles show that the acceleration of the particles is 1.96. So first, let's look at the 12 kilogram particle. This one over here. So since 12 kilograms is to 8 kilograms, right? When they're released, the 12 kilogram particle is going to fall downwards. Right. So our equation again is resultant force would be equal, since this is going downwards, we've got weight and tension going upwards. In order for it to go downwards, weight must be greater than tension. So we've got weight minus tension. Again, it's minus because it's in the opposite direction. Right, and we know resultant force is equal to F is equal to MA. We can substitute, and weight is equal to mg. So we've got MA is equal to mg minus T. We can substitute our mass, which is 12A equals to 12g minus T. G is just 9.8. So that's one equation. For our second equation, for particle 8 kilograms, is the same resultant force. However, this time, this particle will be moving upwards, right? It's going moving up. Still going to have tension going upwards, and still going to have weight going downwards. But since this particle is moving up, the tension must be greater than the weight because it's moving up. So this is equal to tension minus weight, right? So and the opposite direction, so you do minus. The tension must be greater than weight for the particle to go up, so we do tension minus weight. But for the other one, since 12 kilograms is going downwards, weight must be greater than tension, we do weight subtracted by tension. Okay, again, uses these two equations, and you get MA is equal to T minus mg. This time our mass will be at 8 kilograms. We have 8A equals to T minus 8g. There were two equations now. Now we can form simultaneous equations. Let's rearrange this to a nicer form. Plus T is equal to 12 times 9.8. 9.8 is the same as g. For the other equation, we've got 8a minus t to minus 8 times 9.8. And you can put these into your calculator, or you can do it separately if you want, but it's easier to just put it in your calculator. You get a is equal to, should get a is equal to 1.96, and you also get a value for t. T is equal to 94.08 newtons. These are your two answers. So we've done that, right? We showed that it's 1.96 as shown in the question. And part B also relates to part A. But we already found it's fine, we want to find the tension, but we already got the tension already, so that was easy. So we got 9.808, 9.408. Now part C, we want to find the time taken that it takes for the particle to reach speed of 7 seconds, 7 meters per second. So for this, for trying to find the speed, we'll use SUVAT equations. So SUVAT/BU. Right. We want to find a time. We don't know. We know our acceleration of the particle, 1.96. And we know that the final, we want to find it at speed 7 meters per second. So our final will be 7. And since the particle is initially at rest, right, our initial velocity will be 0. So you can use your formula booklet to find which equation suits best. And you should get A is equal to V minus U over T. And we get 1.96 is equal to 7 subtracted by 0 over T. Rearrange, you get T is equal to 3.57 seconds. Let me check that real quick. 1.96. 7 divided by. Yep. And that's it. Those are our answers.